Welcome to qnawire.
Welcome to the problem number 22.34. This is chapter 22, go slow. So in this question we are given that there is a cube which has side L equals to zero point 0.3 meter and one of the corner is at the origin. So this is the cube and this is exactly that equal to the figure 22.6. So we need to find out the flux through each of the surfaces S1, S2, S3, S4 and S5 and S6, and then we will use the go slow to find out the Q inside that, which generates this electric field. So I have written down some information about these surfaces here. So S1 is a surfaces which is made on the xz plane or the parallel to the xz plane at y equals to 0. Similarly, S2 is the surface parallel to xy plane at z equals to L. So this is our S1, which is xz plane. So this is our x, this is z, and this is y. So this is our x S1. And S2 we have xy plane at z equals to L. So we have this one plane. So this is parallel to yx or xy. So this is our S2, and so on and on. So we will use this information to integrate the E dot ds. So let's find out the flux. So flux is known equals to E dot ds. So finding out the flux through the S1 surface, so which is equals to E1 dot ds1. So first talking about the ds1 surface, so we have xz plane at y equals to 0. So this is our surface. So we have this electric field and we have ds vector equals to a vector, or say that, let me write it more clearly. So ds1 vector, which is the area of the S1, so which is ds1 minus j cap. Minus j cap because we have this surface and this surface has direction downward. The area vector has downward direction, so which is ds vector. So we have electric field dot ds1 vector equals to 0 because we don't have any component along y direction or j cap direction. So we have e dot ds1 equals to 0. So therefore flux through s1 is our 0. So our phi s1 is equals to 0. Now going to the s2, so we have flux through s2 equals to e dot ds2. So ds2 we have to find out ds2 first. So ds2 is again, so we have e dot, so ds2 vector is equals to ds times k cap. Looking at the ds2 here, so this is our surface ds2. So this has direction along z direction, so this is our vector. So this is along k cap, so this is we have k cap. So therefore we have e dot ds2 k cap. So taking the dot product with the electric field, so this is the only component we have, 3 z. Now what is ds2? So ds2 is the area of this surface, which is dx dy. So we have dx dy. So this gives us 0 to L and 0 to L because the whole surface goes from dx 0 to L and dx dy also goes from 0 to L. So we have 3z L L. And what is the value of z here? So z is equals to this value, z equals to L. So we have 3L cube. So which means 3 times point. So what is the value of the L? Which is 0.3. So we put it 0.3 here. So cube. So this gives us equals to 0.081 Newton per coulomb meter square. So this is our phi S2. Phi S1. Now going to the phi S3. So we have electric field dot ds3. So ds3 we have ds3 j cap. Now we have j cap, so we don't have any dot product, so dot product goes to 0. So we have phi s3 equals to 0. Now we go to the phi s4. So we have e dot ds4. So ds4 vector is equals to ds4 minus k cap, because the s4 area is xy plane at z equals to 0. So we have this one, and direction of this one is that way, because the surfaces always have direction outward and normal to the surface. So therefore we have k cap here. So we take the dot product here. So this comes us minus 3 z dx dy from 0 to L, 0 to L. So this gives us, yeah. So we have 3z L L, or L square. Now what is the value of the z here? So looking at the z here, so we have z equals to 0 here. So he put 0 here, so this gives us 0. So again phi s4 is 0. Now finding out the phi s5, the flux through the fifth surface. So we have E dot ds5. Now ds5, we're talking about this surface which is yz plane. So this would be ds5 vector should be ds5, which is along I cap, because we have ds5 as our this surface, so which is along I cap. The direction is area to this way. So we put it here. So E dot ds5 I cap. If you take the dot product of this one, so this gives us minus 5 x. So ds5 is our yz plane. So we have dy dz from 0 to L, from 0 to L. So this gives us minus 5x L square. Now what is the value of the x here? So we have x equals to L. That means we have minus 5L cube. So this gives us minus 5 times 0.3 cube Newton per coulomb meter. So this gives us minus 0.135 Newton per coulomb meter. So this is our phi s5. Now going to the phi s6. So we have E dot ds6 vector. So ds vector 6 is along minus I cap, because we have this one here, yz plane. So we have this vector, so this area, and so the direction is this way, which is minus I cap. So phi s6 equals to E dot ds. We have E dot I cap minus ds6. So if you take the product, so this comes out minus 5 times minus ds6. Now ds6 is the plane in yz plane, so we have 5 dy dz. There is a we have x here, so let me write it x here. Yeah, so the integration goes from 0 to L for both dy and dz. So this gives us 5 L square x. So what is the value of the x here? So x is 0, so we have 0 here because x is 0 on this surface. So this is our flux through phi s6. So we have the answer for your part A. This was your part A. Now we go to the part B. So we have E dot ds for the whole cube equals to q enclosed over epsilon naught. So let's add ds1 plus E dot ds2 dot plus E dot ds6. For the all surfaces, the flux, so this is flux S1 plus flux S2 plus dot flux S6 equals to Q enclosed over E naught. So we have Q equals to the Q enclosed equals to E naught total phi. So total phi comes out to be, so the only flux which are known not zero, which is the phi S2 and phi S5. Yeah, that's it. All other are zero. So we have Q equals to E naught times 0.081 minus 0.135. So we have put in the value of the E naught, which is 8.854 into 10 raised to minus 12. So this gives us equals to minus 4.78 into 10 raised to minus 13 coulomb. So Q equals to 4.78 into 10 raised to minus 13 coulomb with negative sign. So that's your answer for your part B, and that is all what we needed to find out. So that's your answer for this question. Thank you for watching the video.